And what we intend to go through during this webinar is, since this Mostra, it's a big event and it's global, I will just do a very brief, quick introduction to SWEP and what we do. Then I will go into the global electrification observations and trends that we can see on a global basis. And then we will boil down more into what is going on in Europe and the EMEA market and the drivers for heat pumps, the different refrigerant trends, and how these trends are affecting the development and what we do with brazed plate heat exchangers. Then we will look at the portfolio, SWEP's brazed plate portfolio, and our technology roadmap and what we're doing to meet all these new standards, legislations, and trends within the heat pump market. And last and briefly, if there is time, I will go into the some extra protection of Sealix that we have. But let's see how we're doing on the time during this webinar. So just very briefly, SWEP is a brazed plate heat exchanger manufacturer. We're around 1,000 employees on a global basis with 5 factories in all the 3 continents in America, EMEA, and APAC. We have a large extent of sales offices. We have R&D in Asia and in Europe. We have warehouses to cover the globe. You see those yellow dots here. So we're covering all the different continents on a global basis. We have been starting the brazed plate journey back in 1983 in a garage outside Landskrona in Sweden, and have expanded on this global platform since then, and have had a long-term investment company owning us since 1994, helping us to have done this journey and made these expansions that are needed. So if we go into the different global observations and trends, we can see for electrification that in turns also drive the heat pump market and the residential heating market. So if we look within EU, we have EU has earmarked 500 billion euro in the new Green Deal that was decided during 2020 to push for renewables and exclude the nuclear and the fossil fuels as energy carrier. So that is a policy direction. You also important is what the banks are doing and how they are redirecting their investment funds. And so they follow towards the renewables from 2021. And they have, the European Investment Bank have earmarked 2 billion euro per year for doing this. And another, just as an example, within the Euro or EU, we have UK that has implemented their 10-point plan as of last year with Boris Johnson for the Green Industrial Revolution. And it's admittedly a very tough high target of 600,000 heat pumps annually by 2028. That is also, they are also focusing on industrial heat pumps there. There you can see gas will, I will have another slide later on, but gas will be for sure be an energy carrier to count on going forward. But there is a push downwards on gas, and you see it in certain countries. You have seen it in Netherlands the recent years, and even UK has made decisions and going in that direction from 2025 for new buildings. Now, when we have a new president-elect of Biden in the US, there is a different tone from that side of the Atlantic, and we have seen a quite dramatic change, and also pushing the electrification within Americas. They have made an executive order from the Biden office to join the Kigali Amendment and also actually the Paris Agreement. They have put in place a $2 trillion investment plan that is focused on green initiatives. They have set a goal to decarbonize the electricity by 2035. But on the other hand, and here they need to tiptoe to manage their political landscape. There are no signs of any bans on gas, or for that sake, for the oil fracking that certain states have banned or put pressure on. If we look on the other side within APAC and looking at China, they have very recently approved their new 5-year plan, their energy revolution, where they have a focus on electricity, natural gas, and a lot of investments into R&D and focusing on the energy efficiency to manage the energy need they have the coming years. The last 5-year plan, we saw a very big push on what is called the coal to electric, specifically in the north of China, where those incentives took really a place. We still see it's not at the strong pace that it was in 2017 to 19, but we still see a benefit on those incentives and pushing the heat pump market in China forward. And there are also other initiatives and more on a commercial basis in the Pearl Delta, where we see the mini chiller / heat pump business growing in a fast pace. This new plan for 5-year plan is focusing on the urbanization. I think they want to go from 60% up to 65% of urbanization. And that is driving electrification and also comfort, which will fall into the heat pump market / chiller, mini chiller market. Also within Japan, you have 3/4 of Japan's pipeline for coal power back in 2015. Now we see it's very unlikely that will proceed, and all the investors are more moving into renewable energies. And International Energy Agency is foreseeing a bounce back because the electricity market and the energy market went down during 2020 and the COVID and the different lockdowns we had on a global basis. And we foresee, or IEA is foreseeing, a pretty good rebound from that downturn during last year. So if I go to the next one, and here the message is it is an electrified future we are seeing. And here is the energy map from 2016 and how IEA and the International Renewable Agency is seeing the map for 2050. And you see a very big increase of the electricity from 19% up to almost 50%. And with a focus because in 2016, the electricity and the renewable share was only 24%. And we see a strong development primarily within the wind power, but also on the solar panels that is expanding on a global basis. And if that is continuing at a good pace, the goal is to reach the 86% of renewable share. And you can see that the main hits will come on the oil and the coal that needs to go down. Gas will go down slightly, but still it will be an energy carrier to count on. Traditional biomass versus modern biomass. I've seen some figures that, for example, if we look in Europe and in Germany, that has during 2020 had a massive impact and very high increase during 2020, even though it was a COVID year. We also have the district heating up here will be an energy carrier. That is because everything cannot be electricity. So we need other heating and energy carriers to manage the need and the comfort. It can be said that we have the electricity grid and we need technologies, for example, smart heat pumps to manage this fluctuating demand and have the flexibility in the energy grids to manage the demand and the need for the future. Here we have the development. If we look on the development, the recent 10-15 years, we had a peak back in 2006, 7, and 8, also driven by incentives within EMEA. These figures are for Europe, and we utilize the European Heat Pump Association's collected figures that they collect every year. And the big push that has happened the recent years. As examples, we had in 2019 a growth of up to 37% on the air-to-water heat pumps. The ground sourced has been more stable over the years, even though it had a 6% increase in 2019. Hot water heat pumps had seen a very good growth, mainly driven from France. And overall, if we include also the air-to-air heat pumps with heating, that should be said, it was an 18% growth. I have not yet seen the European Heat Pump Association's collected figures on a European level, but I've seen indications that even though it was a COVID year, it landed around 13% for 2020 versus 2019. And for Germany, that has had a very good or strong incentive plan put in place. We have seen a growth of 40% on heat pumps, both air sourced and ground sourced during 2020. So there is big increases. Moving more, which is constantly a hot topic the recent year and will be the coming years going forward. The main drivers for the refrigerant change that is happening and the low global warming potential refrigerants that are used. We have the Kigali Amendment and Montreal Protocol on a global basis pushing the phase out of HFCs with a goal to 2036. Within EU, we have stronger goals and tougher goals for renewables and electricity. We have the F-gas that were put in place in 2015. And now in 2021, we see the next step from the reference back in 2015 with counting the global warming potential of the refrigerants. We need to lower that down to 45% this year. And all this is affecting what refrigerants are used on the market, and there are many right now, and how that also is affecting SWEP and the developments that we are doing. We have the eco design that is pushing for high seasonal efficiency more than in the past. It's promoting the below 150 and the global warming potential on the refrigerants, and also the low water pressure drop. If I move down to the market trends, we see the energy directives for the building directive for energy efficiency is driving better insulated houses. We see that, for example, the super bonus in Italy recently has been a very big push in 2020 and continuing in 2021. That is one example of this. It is pushing capacities downwards. If the houses are better insulated, it pushes capacities of heat pumps downwards, and also including the comfort cooling. However, it has to be weighted to the retrofit. That is also a very big market, and recently in France, for example, that has been in a lot of retrofits. That is pushing the capacity upwards. We have the global warming potential and the natural refrigerants. I have that on a separate slide. We'll speak specifically on that. We see also more reversed systems and cooling. This has been the case in APAC and China and the APAC countries for a long time. We see that developing more strongly also now in Europe. Here, this is the refrigerant. If we look at the refrigerants on the market from the today 410A and 407C for the ground sourced heat pumps. If we look at the air sourced heat pumps, the main contenders that are developing right now, it's the R32 and propane. A lot of the development has happened the recent years, from 2018 and 20, with entering the market as we speak, and many launches now during Mostra as well, of course. There are other refrigerants as well, but they are used in not as big extent, with the 454B and 454C, for example. You can see up to the right-hand side here, the 50 to 60% is what we see on the market, is in the estimate of how much the R32 is utilized within Europe. Propane is a little bit lower. We estimate that to 35 to 40%, and the rest lands on the other refrigerants, where the main ones is the 454C and 454B. And to say within these, the only long-term solution is the propane, since it has the very low global warming potential of 3. We have the 454C that is below 150, that is also a long-term solution. While the other ones either need to be developed and or need to redevelop the heat pumps for the future within probably a 5-year period to find the next alternatives that will occur on the market. Within heat pumps, it is not as clear trend right now. Those developments are ongoing, and many of the companies are making their decisions right now, and they are discussing it internally. We see the runner-ups, I think, is R32. Propane has it tougher here because it's more in-house, and then the regulations, or it's tougher to manage. But we do see that some go and are trying out also propane. But R32 is a runner-up. 454C with a glide has bigger potentials to be efficient and a good refrigerant for ground source heat pumps. And so how this is affecting SWEP as a brazed plate heat manufacturer, and what we do to develop towards these trends within the heat pump market. So all these new refrigerants with low global warming potential and the natural refrigerants, they all have different characteristics. And we need to adapt our heat exchangers to that, of course. But since in the past it was more easy because we only had one to look at, and 410A basically within the heat pumps. And now when it's several different to choose from, we need to work on the platform. And when we are developing the new products, we have a platform where we can use different plates to cover and manage depending on what refrigerant you are using, and of course also what type of specification and the COP and the characteristics of the heat pump. We also need to adapt to a new distribution and improve our distribution to have very good evaporators to cover for the ground source heat pumps, but also for the reversibility and the cooling mode on the current air source heat pumps. It is a push since most of the refrigerants are flammable or mildly flammable or highly flammable as propane. There is a push to have a low refrigerant charge. So we are working with our pressing depth and the asymmetry and the pitch on our heat exchangers to minimize this refrigerant charge. And we have recently developed a new next generation of asymmetry. So we can adapt to have a low refrigerant charge, having the optimum heat transfer, and still have a very low water pressure drop. Because the new eco design in EU, but we also see this in APAC very importantly, where we need to still have a very high heat transfer, but lowering the water pressure drop. And that is a new balance, and have needed a new development of the asymmetry in the current heat exchangers. We have to manage we have mixture of plates to manage either tight or medium temperature approaches on the heat pumps to manage the required COPs. With the new refrigerants, we see different subcooling or higher subcooling than we have seen in the past. I think specifically for propane. So to manage the seasonal efficiency, the seasonal COP, there is a push upwards in the subcooling, but to look in the total system to find that right balance, not to have too high subcooling and not too low. That is the challenge for the heat pump manufacturers, and where we are also optimizing our heat exchangers to meet that. From a safety solution perspective, we are developing our double wall technology. I will speak specifically on that in a slide later on. There are many different ways the heat pump manufacturers can use sniffers. You can have a more venting system. But one way to do it is also to use the double wall. There are some downsides with loss of heat transfer efficiency. And also the cost, of course, when you have a double wall is a little bit higher than a single wall. But you do have a very safe solution where you will not mix the fluids. So these are the main things we are working on going forward with a heat pump and the roadmap of SWEP. I've spoken on it. We have the next generation of asymmetry to meet new refrigerants and deliver the low water pressure drop. SWEP was the first company introducing asymmetry back in 2008. It was on the smaller units that are used in boilers, as you might know. And so we have developed this over the years, and now we see a new step change of utilizing this to meet the heat transfer needs and the low water pressure drops that the market is requiring. We have developed a product, Sealix, that is a thin silicon dioxide layer covered on the heat exchanger to manage tougher conditions with primarily corrosion. It also helps against scaling and fouling. We are developing the next generation of our distribution system to make it very cost competitive and improving the efficiency with the new refrigerants available on the market. We're developing right now the next generation heat pump condenser aimed at the new refrigerants and the air to water systems, heat pump systems, and the next generation of double walls. So here is the platform that we can choose from today within SWEP. We have, if you have a lower capacities, we have the small sized units, very highly efficient, where you are below 10 kilowatts. And then if you have up to 25 kilowatts, you have a different platform to choose from with a 20 size, our next generation, the 26 and the 80 size units. And it is in the toolbox needed to have several different platforms to manage the different requirements. For example, if you have a hold up volume on your heat exchanger, you need to balance the air coil. Every manufacturer are doing this differently and have different requirements, and therefore we need to have a big platform and many units to choose from to fit your requirements the best. I will move on here. So these are our next developments on the next generation condenser and evaporator for the heat pump market. We do focus on the propane and the R32 with a very good fit to the other refrigerants on the market that are quite similar to primarily the R32, I would say. They are mixes of containing some of the same mixes here. We are managing dedicated to the new refrigerants. We do have different plates to combine to have the optimal performance for the right temperature approach and the water pressure drop. We have developed the new asymmetry and the very high asymmetry with new technology and new patents to manage this. We have focused on the new distribution system in this new product to manage the reversibility in air-cooled or air-sourced heat pumps, to also manage on the evaporation duty that in the past has mainly been focused on defrosting, but more and more we see the trend of cooling. We have we are focusing on lean production, and our most highly automized production cell so far within SWEP. So very little manual labor are put into this manufacturing. And here we have the double wall that we are developing and will be available during this year. Will have the highest heat transfer on the market from a double wall perspective, and also with asymmetry, so we have a very low water pressure drop on the water side that fits the heat pump market very well, and a low hold up volume on the refrigerant side. This is a new technology. We have the other technology that we have in our older heat exchangers of the 16 double wall and 35T, where the leakage is out on the side. Here we have other channels inside the heat exchanger with the leakage on the short end. And one of the advantages of this, if you want to have a higher utilizing digitalization and put certain sensors to detect leakage, you will only have leakage in one place where you can put your sensor to make these detections. To save some time, I will skip this one because I want to save some time also for some questions at the end here. Since we are getting close to our timeline. So I hope you will enjoy the Mostra show. I will be there. We have our digital booth where you can come and visit us. If you want, here is also the contact details if you want to get in contact through email or telephone with me. And please take the opportunity during the Mostra show to come and visit us in our booth and see what we have to offer. And we can go more in deep depth of the different things presented here today. So we have, for you who have the time to stay, we can have some questions and answers at the end of this show. So please feel free to use the chat or otherwise just unmute and we can take it directly. Anyone has any questions? If not, I think we can round off this session. And again, please feel free to join us in the booth and make contact during the Mostra show. Thank you very much for listening and enjoy Mostra.
Anton, we just had a question in the chat here.
Okay.
In the latest hour, from Basan Badran, who's wondering, he's working with HFOs, and he's wondering if we can use the next generation condenser with HFOs.
Absolutely, Bassam. We can do that. Feel free if you want to unmute if you have any specific refrigerant that you are using or thinking of. But that is for definitely possible. Yes, feel free to contact me afterwards. That's good. I see the chat now as well, so thank you, Tom, for highlighting it. Okay. If nothing else pops up here, I will zoom out and join the Mostra show. So thank you very much and have a very nice day. Bye-bye.